Hello and welcome back to the channel. Today we are diving into one of the fundamental concepts in real analysis, discontinuity. We will explore the three main types of discontinuities as you will encounter in functions: jump, removable, and infinite discontinuities. And of course, we will look at examples to help you understand them better. Let's get started. First, let's define what a discontinuity is. A function is continuous at a point if the limit of the function as it approaches that point equals the function's value at the point. If the condition is not met, then the function has a discontinuity at that point. So first, a function is continuous at a point if the limit of the function as it approaches that point equals the function's value at the point. This is the condition for continuous. Now, if the condition is not met, then the function has a discontinuity at that point. Let's break down the different types of discontinuities. Let's start with the jump discontinuity. Let's start with the jump discontinuity. A jump discontinuity occurs when the left-hand and right-hand limits of the function exist, but are not equal to each other. The function jumps from one value to another, which creates a gap in the graph. So let's have a look at this example. Consider the following piecewise function. We we have function f of x equals to 1 if x less than 2, and f of x equals to 3 if x greater and equals to 2. So the graph will look like this. We have x equals to 2. When f of x equals to 1, x less than 2. And when f of x equals to 3, we have the condition if x greater or equals to 2. So we will have a point here, because x will also equals to 2. Okay, this is the graph of the function with a visible jump at x equals to 2. So at x equals to 2, the left-hand limit is 1 and the right-hand limit is 3, but the function itself takes the value 3. The function jumps from 1 to 3 at x equals to 2. So we have a jump discontinuity. In this case, the function has a jump at x equals to 2 because the limit from left is not equals to the limit from the right. This type of discontinuity is common in functions that are piecewise defined. Now, next example, let's look at it. Infinite discontinuity. This is we will have infinite discontinuity. This happens when a function approaches infinity or negative infinity as it gets close to a certain point. Essentially, the function blows up or goes to infinity. Let's look at the function. For this example, we have f of x equals to 1 over x minus 1. At x equals to 1, the function is undefined. So x is not equals to 1. Let's look at the graph of this function. And this is the function f of x equals to 1 over x minus 1. So, as you can see, at x equals to 1, the function is undefined because it has a vertical asymptote. As x approaches to 1, from the left, the function values goes to negative infinity. And as x approaches to 1 from the right, the function values go to positive infinity. This is an example of an infinite discontinuity. An infinite discontinuity occurs when the function becomes unbounded near a point, causing the function to shoot up or fall off without a finite limit. The function doesn't approach any real number as we approach the point. It just goes to infinity. So this example, the function f of x, 1 over x minus 1, it has a vertical asymptote. At x equals to 1. So this gives us a infinite discontinuity So next, removable discontinuity. We have the removable discontinuity. A removable discontinuity occurs when the limit of the function exists at a point, but the function is either not defined at that point or is defined incorrectly. So, consider the example. Consider the function f of x equals to x squared minus 1 over x minus 1. For x n equals to 1, and let's say we define f of 1 equals to 2. So in this case, we can define the function. So first, we simplify the function. Now we have f of x equals to x squared minus 1 over x minus 1, which equals to x minus 1, x plus 1 over x minus 1. So in this case, we can cancel this term and this term. So we just left with x plus 1 for x n equals to 1. So our function can be written as x plus 1 and x So notice that the function is not defined at x equals to 1 because the denominator is 0. The denominator is 0 at x equals to 1, even though the limit of f of x as x approaches to 1 is 2. The function has a hole at x equals to 1 because it's not defined there. Let's draw the function again here, f of x, and we have so the limit of f of x as x approaches to 1 is 2. The function has a hole at x equals to 1 because it's not defining here. But if we were to define f of 1, f of 1 equals to 2, we would remove the discontinuity, making the function continuous at that point. So in this case, the discontinuity is removable because we can redefine the function at that point to make it continuous. This is why it's called a removable discontinuity. We can fill in the hole by defining the function properly. So now let's sum up. First, jump discontinuity, the function jumps between two different values at a certain point. The second, infinite discontinuity, so the first jump discontinuity is the function jumps between two different values at a certain point. And the second is infinite discontinuity. The function approaches infinity or negative infinity as it approaches a point. And next, removable discontinuity. The limit exists at a point. But the function is either not defined there or defined incorrectly. So thanks for watching, and I hope this video helped you understand the different types of discontinuity in real analysis. Don't forget to like, subscribe, and leave a comment below if you have any questions or if you would like to see more examples. See you next time.